So this is May 2016 and it's question 15a. Okay, so the question is asking us to calculate the saponification value of the fat. And before we do that, we need to think about the chemistry that's happening here. And that's explained at the start of the question in part A. So think about the process that's happening here. You've got 9 grams of your fat and you are reacting it with potassium hydroxide. Ethanolic just means that it's dissolved in ethanol as a common solvent. So you've got your fat, you've added in a known volume and concentration of potassium hydroxide, and that reacts with the fat, completely hydrolyzes it. But we've got some excess potassium hydroxide. So what we do is we then react the excess potassium hydroxide with hydrochloric acid. We titrate it against that to work out how much potassium hydroxide didn't react. So this is like a back titration type of calculation. So thinking about equations for what's happening here, you've got your fat and you're reacting that with potassium hydroxide. You're going to need 3 moles of potassium hydroxide because there's 3 fatty acid ester units to hydrolyze. And that's going to give us glycerol and our 3 soaps. That's just the fatty acid chain, but it's the potassium salt of the fatty acid chain. So this is a hydrolysis reaction. So we're adding in a known volume of our potassium hydroxide, but it's an excess amount. So what we then do is take the excess potassium hydroxide and we react it with hydrochloric acid. That will give us potassium chloride and water. Okay, so we start at the end of the reaction as such, and we can see that we're titrating it against 0.5 molar hydrochloric acid, and we can see that we needed 15 centimetres cubed of it. So we work out firstly the number of moles of hydrochloric acid that we used. So the concentration is 0.5 molar and the volume is 0.015. That's converting the 15 centimetres cubed into 15 decimetre cubed. That works out as 0.0075 moles of hydrochloric acid was needed to neutralise the excess potassium hydroxide. So I can then work out how much excess potassium hydroxide I had. This is a 1-to-1 ratio. So that means the number of moles of unreacted potassium hydroxide was 0.0075 moles. So that's the excess or unreacted potassium hydroxide. So then I want to be able to work out how much potassium hydroxide did react. And in order to do that, I need to look at how much I added in the first place. So in the first place, I added 50 centimetres cubed of 1 molar potassium hydroxide. So the initial potassium hydroxide added, I want to work out the number of moles, so I use the equation N equals CV. The concentration is 1 molar and the volume is 0.05 decimetres cubed. And that gives me a total of 0.05 moles. Okay, and that's how much I added in the first place, but that was an excess amount. So in order to work out how much did react, I take my initial minus the number of moles that were reacted. So the KOH used to hydrolyze my fat is going to be the initial minus the unreacted, so that's 0.05 minus what didn't react, and that leaves us with 0.0425 moles, and that's the number of moles of potassium hydroxide that did react. To continue this calculation, I then need to think of the definition of my saponification value, and it is the mass of potassium hydroxide in milligrams required to completely hydrolyze 1 gram of fat. Okay, so I've got the number of moles of potassium hydroxide, but I can see I need the mass of potassium hydroxide. So mass of potassium hydroxide is number of moles times your RFM. The number of moles of reacted potassium hydroxide was 0.0425. RFM is 56, and that gives us a mass of 2.38 grams. That's in grams. We can see from my definition that I need it in milligrams, so I just times by 1,000, and that gets me 2,380 milligrams. But we notice from the question that I have 9 grams of fat. So that value is telling me that I would need 2,380 milligrams to completely hydrolyse 9 grams of fat. But looking back to my definition for saponification value, I need it for 1 gram of fat. So this is for 9 grams of fat. So for 1 gram of fat, I simply do 2,380 milligrams over the 9 grams of fat that I did have, and I want it for 1 gram of fat, so just times by 1, or just divide by the mass of fat that you have. It all works out the same, and that gives you a value of 264 milligrams. And that's your final answer. That means that 264 milligrams of potassium hydroxide is required to completely hydrolyse 9 grams of this fat.